Hi, my dear friends. Welcome back to another Python tutorial class. And in this class, we shall see operators in Python. What are the various types of operators? So, first of all, we have here, as you can see, arithmetic operators. These are used for arithmetic functions. And here, int or float, these are applicable. Okay. So, first of all, arithmetic operators now, like addition operations, subtraction operations. Okay. Then you have float division operations. Float division operations mean where the output you will get will have your decimal point. Then multiplication operations, float division operations. Okay, float division operations like where the division will happen and after that rounding off will happen. So after that you have exponent operations, modulo operations. All of these they come under the arithmetic operators. Okay. So for example, here you have these two variables x and y. X is 52, y is 10. Simple. Print x plus y, print x minus y, print y minus x, print x into y. Correspondingly, you will get your addition, then subtraction and multiplication results. Okay. Just run this cell. Then next you have, suppose here in this next cell, here you have these two variables, x equals to 7, y is equals to 2, and print x by y. This is your float division. So when you will do this x by y, then ultimately 7 by 2 is nothing but your 3.5 with decimal point. And here if you do this print x, print then within brackets x, and after that these two slashes, backslashes, and then you have the second variable y. So x, here you have your x, and after that you give two backslashes, and after that you give your second variable y. So this will be float division, x divided by y, but float division. So 7 by 2 is your 3.5, and float division will do what? It will do rounding off. Rounding off means in Python, this value will be converted, this value will be converted to a round figure. 3.5 will be converted to a round figure, which is 3. As I previously told you, in Python, even if you have 3.9 and you do round off, you do the round off on it, then it shall be converted to 3. And same goes for, say, you have 8.9. Then 8.9 won't be rounded off to 9. It will be rather rounded off to 8. Okay. And then you have modulo division, that is print, then give the first variable x, then this is the percentage sign. This is the percentage sign. It is for modulo operation. And then you give the second variable y. Okay, so x, then give the percentage sign y. This will be your modulo operation, x modulo y. In modulo operation, what happens? Ultimately, the remainder value you will get after the float division. Remainder value you will get. So, like for example, 7 by 2. 7 by 2. So what will be your quotient? That will be 3, isn't it? 2 3s are 6. 2 into 3 is 6, and 6 will come below 7. 7 minus 6 is 1, and this 1 will be the remainder, and that will be displayed in the console output. Okay. Now, with negative sign, like x is equals to minus 6.6 and y is equals to 2. And again, here you do your float division, minus 6.6 divided by 2. That will give you minus 3.3. Then here you have print x, float division y, floor division y. So minus 6.6 divided by 2, it is minus 3.3. And in case of negative sign, magnitude wise, it shall be rounded off. Here you have minus 3.3, so like it will be rounded off to the other highest state level magnitude wise. Like for example, minus 3 minus, if you give comment here, minus 3.3, it gets converted to or gets rounded off to minus 4. Magnitude wise, when you have negative, then magnitude wise gets rounded off to the next highest state. Or conversely, if you want to say, you can say that this entire negative thing, this negative 3.3 gets converted to a lower state, because minus 4 is lesser than minus 3.3, isn't it? So if you consider magnitude wise only, you can say that when you have minus and a number, then magnitude wise, this number will be converted to a higher magnitude. Like 3.3 got converted to 4, and definitely the minus sign will remain. Or otherwise, you can say minus the number, that is 3.3, shall get converted, or shall get get converted or rounded off to the next lowest state, which is minus 4, and minus 4 is lesser than minus 3.3. And in case of positive, you know that in case of positive, the magnitude will get reduced. Like in case of 7 by 2, if you in case of, like, say for example, 7 by 2, 3.5 is there, and it shall get converted, it shall get rounded off to a lower value magnitude wise, which is 3. And in case of negative, it shall get rounded off to a higher value magnitude wise, like minus 3.3 got converted to 4, and minus sign will remain. Okay. And like if you want to do the modulo operation in case of a negative number, like minus 6.6 and minus 6.6, then you do the modulo with respect to y. What is y? It is 2. So minus x is already in negative format. X is what? Minus 6.6, isn't it? Then you have percentage sign, which is for modulo operation, and give the second variable, which is 2. So in that scenario, what you have to do is just besides this negative number, you have to provide a minus, and then outside another minus. Then you will get the correct result. So like minus 6.6 modulo 2, it means what? Like minus 6.6 modulo 2. This shall give you like minus 3 will be the quotient, minus 3 will be the quotient, and below minus 6.6, what will come? Minus 6 will only come, isn't it? So then you will do the plus, that is minus 6.6 and minus 6, and a plus will come here, that is plus sign will come here. It will, the sign will get changed, isn't it? So that will give you what? That will give you minus 0.6, minus 0.6. So that's what it does here. It here inside the Python, it gets like it gets into the interior, like minus 0.5, all these nines, and in the last you have 6. So minus 0.5 and all these nines, and then 6. That means it is approx minus 0.6 only, nearest approximation. Okay. So in case you have negative number, then just besides x, you have to give the negative sign, then close the bracket, and then outside the bracket you have to provide another negative sign. Okay. If you don't do this, then you will get incorrect answer. You can try it out once. And this print, if I give, then there will be a space. Like here you can see 3.5, 3 and 1, and then there is a space here. This space arrived why? Because I gave a print here, print then blank. So basically for this entire operation, whatever results will come, they will appear after the space. Okay. Then again you give this print blank print function, and after that you give another operation like this, and the results will come after your space. These are the results that come after the space. Okay. So like minus 2, and here you have 6. So float division, minus 2 by 6. You get your minus 0 point, all these threes. Then you have float division, minus 2, float division 6. So here you have minus 0 point, all these threes. Magnitude wise, it will get converted to the next highest level, that is 1, isn't it? All these, that is 0.333. 0.333 will get converted to the next highest level, which will be 1. Magnitude wise, it gets converted to the next highest magnitude, but the negative sign will remain. So altogether, you can say that this output will definitely give me a negative value, which will be lower than this particular negative value. Okay, after the float division. And again, if you want to do the modulo operation, then you will have to use the percentage operator. between these two variables x and y. So x percentage y means x modulo y. Remainder will remain. Now since here x is negative, so that's why here besides x you have to use the negative sign, and then outside also you have to use a negative sign, and then you will get the correct remainder. Okay, what will be the remainder in this case? It will be definitely minus 2 only. Minus 2 by 6. If you do your minus 2 by 6, that means 0 will appear as the quotient, and below minus 2 what will appear? 0 only will appear, so the remainder will be minus 2 only. Okay, so if you just run this cell, here you go. Now, math, as I told you in the first class, that here in Python, here in Anaconda environment, it is a package distribution platform where a number of libraries are provided, and under each library you will have many modules, and those modules will have functions. Okay, so import math. This math is a module. Okay, what will happen with this? Now, see, for example, x is equals to 6, you have to first import it. Okay, run this cell. Yeah. Now x is equals to 6.3. This is a variable. Print math dot, when this with this dot operator, then after that you can access a function, because under this math module you will have several functions, and to access these functions you will have to write this module name, which is math, and then you will have to write this dot, and then only you can access the functions which are available under a particular module. Like in this case of math, which is a module, under this math module you will be able to access a number of functions like floor. So 6.3, it will be converted when you do this print math.floor and you pass the variable x, then 6.3 will be converted to its next lowest level. You are doing rounding off. Okay, so by default, also we saw that it gets rounded off to the next lowest level. So 6.3 will be converted to 6. And if you do math.ceil and you pass x here, then this will convert the number to its next highest level. So for 6.3, the next highest level will be your 7. Okay. And even if you do 6.9, then also the logic remains the same. Here, since I have you first of all, in case of these functions, you will have to import the module, which is in our case math module. Then in order to access the functions under a particular module like math module, you will have to write the math module, and then in order to access the functions, you will also have to write this dot operator. And after this, you will have to give the function. And these functions only will be accessible if they are present under this particular module, like floor and ceil are the two functions which are available under the math module in this Anaconda environment. And then inside this, you can pass the variables. Now, even in case of 6.9 also, this print math.floorx, it shall convert 6.9 to 6, and math.ceilx shall convert 6.9 to 7. If I run this, okay, same thing. And in case of minus, just the opposite happens magnitude wise. In case of minus, okay, like for example, here you have x is equals to minus 6.3. Then print math.floorx. If you run this, then you see in this case, magnitude wise, 6.3 gets converted to the next highest level, which is 7, and the minus sign will definitely remain here. And in case of ceil, just the opposite will happen. Print math.ceilx. What it will do here? It will convert this 6.3 magnitude to its next lowest level, which is 6, and definitely minus sign will appear here. So in case of minus number, the operations will be reversed magnitude wise. Okay, so just run this. Yeah, and then you have x equals to 4, and then print x to the power 2, like this will be your to the power operation. Okay, this will be your to the power operation, like exponent operation. Okay, so 4 x is what? 4 to the power 2 is 16. Okay, then further you can try with other numbers like print 3 to the power minus 3. This double asterisk will be used for exponent, that is to the power. 3 to the power minus 3 will give you this 0.037037 dot dot dot. Okay, then similarly for square root, we know the square root means to the power half. That means to the power 0.5. So here the number is x equals to 25, and print x to the power zero point 0.5. That means here you're doing the square root of x, because square root means to the power half, that means to the power zero point 0.5. So square root of 25 is nothing but your 5 only. Okay, if you run this particular cell, then further there is this function sqrt. Instead of going via that exponent operation, you can also go for this particular function sqrt. It is for the square root function only, and this function is accessible under the math module. So in order to access this math module, in order to access this sqrt function which is available under the math module, you will have to import the math module at first, which we have done. Then you have to use this dot operator. After that, you can access the function. So you can write the function and then pass a variable if it is defined, otherwise directly a number like math dot square root of 100 will give you nothing but 10 only. Okay. And if you want to see what are the functions available under the math module, then directly you can use this particular function, print dir directory. Okay. And then pass, and then inside this dir function, you can write math, 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 and then run this cell. And here you go, all these functions that you can see here, like for example a cos h, a sin h, a tan 2, a tan h, lcm, remainder, then mma, log, then here you can see a sin h, sqrt, tan h, tau, trunc, all these things. These are what? These are the functions available under the math module. Okay. And definitely, if you want to see what are the functions available under the math module, then you will have to import the math module at first. Okay, so just you have to run it. And this was about the math operator. Then next we have logical operators. Logical operators. What are logical operators? These are the operators that follow the principles outlined in truth tables. We know the truth tables. A and B, suppose, are the two variables. Under that, you have some values 0, 0, 0, 1, 1, 0, 1, 1, and based on that, you have the output. Okay. So these operators, they follow the principles outlined in truth tables. They work exclusively with Boolean values such as true and false. The result produced by these operators is always a Boolean value. Okay. Please remember, the result produced by these operators is always a Boolean value. The only two Boolean values are true and false. Okay. And mainly three types of logical operators we have. What are these? And operator, or operator, not operator. Okay. So these are the three logical operators. Logical. What are these logical operators? The three logical operators: and, or, and not. Okay. And you come down here, then you give logical operator. First, we shall look into the and operator. Okay. What does this AND operator do? The AND operator evaluates expressions looking for a false value. Okay, the AND operator is always looking for a false value. It immediately, this AND operator, it immediately returns false when a false is encountered. Okay, so if we have one false and one true, then immediately it will return the false because it is always looking for a false value. That's why. If no false is found, it returns the last true. Okay, if there are two trues present, one true and second true, then it will print the second true, because after the first true, it will still look for false. And if it doesn't get, and the second true is the last one, then it will basically return the second true. That is the last true, because it is looking for false. Okay. Then you have the result of true and true is true, while any other combination involving false results in false. This is for the AND operator. If you have a true and true, the second true will be printed. Otherwise, any false, if it is there, even if there is first false, then first false will be printed as soon as it gets the first false. Otherwise, if the false is present like in the second position, like true and false, then the false will be only returned by the AND operator. So let's see, like here you can see print true and false. And operator is always looking for false. Here you have the and operator. Okay, always looking for false. So this false is returned, as you can see in the output console. Then you have print false and true. So here is it gets the false at the very first position only. So this false is returned. All right. Then you have print false and false. Here, what happens? As soon as it gets false, then this that is the first false only. As soon as it gets false, then this false will be returned. Here it gets the false in the first position, so this first false will be returned immediately. Okay, and then you have print true and true. So it will just first come into this position, it will come into this first position looking for false, doesn't get false, it is true. Then the AND operator searches for false again in this location, it says no, again true. So it can only return this second true only. So this second true shall be returned here in the output console. So just run this particular cell. Yeah, now let us test with some numbers. Okay. Now like print 10 and 20. 10 and 20. See, here do we have any blank? No blank, nothing. Okay. So no zero also. So here you have 10, which is true. Here you have 20, which is also true. An AND operator is always looking for false. Here it is true, and here it is also true. So it couldn't find false. It will return the second true, which is your 20, which is your 20. Then print, again you have print, and inside this you have this particular tuple. What is the value of this tuple? Like the tuple contains 11, 22, 44, and then you're writing this AND operator, and here you're giving an empty list. This list contains nothing, and nothing means blank, nothing means absolutely vacant. So that this will be treated as false. There is no value here. Okay, and here inside this tuple, this is populated with values, so this will be true and this will be false. So AND operator at first looks, it is always looking for false. Here it couldn't find false, it found true. Further looks for false, here it found the false, and so it shall return the empty list, this one. Okay, then here you have an empty, you cannot call it this as a tuple. Empty first brackets, empty first brackets contains nothing, so this will be false. And here you have a list, and the list is populated with values 11, 22, 100, so this will be true. So as soon as AND operator finds false, it returns false, so this one will be returned, these empty first brackets. And then you have print. Here you have empty curly braces, give the AND operator, and then give this, like for example, here you have the empty list. So here you have empty curly braces, and here you have empty list. So this will be your false, and this will be also your false. Okay, this empty curly braces will be false, empty list will be also false. And operator is always looking for false. As soon as it finds false, returns the false. Here it finds the false in the first position only, so the first false will be returned, which is your curly braces. And the last one you can already guess, print. Then here there is a hypothetical name Anna, then and operator you give, and there is another hypothetical name Rohit. So this shall here we do not have any blank values, so here this is true because there is a value, and here also you have a value. Okay, so this will be also true. So which will be returned? The second true will be returned, which is your Rohit. These are hypothetical names. So just run this cell. Okay. Then the next logical operator. Then the next logical operator is your OR operator. Okay, OR operator is the next logical operator. It just operates in the reverse way. Like for example, the OR operator evaluates expressions looking for a true value. So OR operator, just contrary to the AND operator, the AND operator is always looking for false value, whereas the OR operator is always looking for a true value. Okay, then it immediately returns true upon encountering the first true. As soon as it finds true, it will return the true. First true, if it finds out, returns the first true. Second true, if it finds out, it will return the second true, provided that the first one is false. Okay. And if no true is found, it returns the last false. So if you have false and false, then the second false, that is the last false, shall be returned by the OR operator. The result of false or false is false, while any other combination involving true results in true. Okay, so it is always looking for true. As soon as it finds true, it returns true. Otherwise, it will return the last false. just opposite to that of the AND operator. Now, for example, here you have this. You have print, then inside true, and then give the OR operator, write the OR operator, okay, OR, and then give false. Here it finds the true in the very first position, so returns true as soon as it finds. The OR operator is always looking for true. As soon as it finds true, returns true. Now, then here in the second one, false or true. Now here at the first position, it couldn't find true. It found false, so continues looking. Here in the second location, it found true, so returns true. All right. Then here you have print true or true. Here it's a very merry-making situation for the OR operator. In the very first location only, it found true, so it returns this first true. And here in the last scenario, you have false or false. So the OR operator is always looking for true. Here it couldn't find true. Further keeps on looking. Here it also couldn't find true. In the first, it found false, and in the second also it found false, so returns false. Second false, it returns here. Okay, so just run this particular cell. Yeah. Then again, the same example values with respect to your AND operator. Here for the OR operator also, like print, then inside the print function, Anna, here there is a string value, then you give the OR operator, and Rohit, this is also string value. So this is also true, and Anna is true, and this is also true. So first true will be returned in case of OR operator, because here you're using OR operator. First true is returned, which is your Anna. Then print, here you have a list. Is it an empty list? It is not an empty list. Inside this you've got values 13, 12, 14. Then give the OR operator here, and after that you give your another argument. Here you have an empty string. Nothing is there. Okay, absolutely blank. So this is false. Now what will happen? So this is true and this is false. OR operator returns the true as soon as it finds it. So the here this true will be returned. Hence you have 13, 12, 14. Okay, and then here you have empty string, nothing inside it. Then you give the OR operator. Then here you give these curly braces. That is, it is a set. Inside this you have values 32, 23, 21. So it is not blank, it has got values. So this one is false and this is your true. And as soon as it finds true, returns true. So it returns 32, 21, 23. Okay, this true. This particular last component, which is your true. And then here you have empty first brackets, nothing inside these two first brackets. Okay, inside these first brackets you don't have anything. Then you give the OR operator, then you give the curly braces. These are empty curly braces, no value inside. So OR operator is always looking for true. Here it found false, so moves ahead. Here it also found false, and after that nothing else, so it shall return the second false here, which is your empty curly braces. So just run this particular cell, and here we go. Then the third logical operator is your NOT operator. Third logical operator is your NOT operator. What does it say? The NOT operator is a unary operator. The NOT operator is a unary operator, meaning it operates on a single operand. That's why it is known as a unary operator. And it returns the negation or opposite of the given value. Okay, so opposite value is always returned by the not operator, which is a logical operator. Like for example, here you see print, then here I have used this not operator, and after that you have given false, and here print not true. So what will happen? Not will always give you, the not operator will always give you the opposite value. So what is the opposite value of false? It is true. So that's why you get true here. And what is the opposite value of true? It is always false. So you will get false here. Okay. So just run this particular cell. Then here you have print, print, not, and then after that, what do you have? Empty, absolutely empty string. That means it is false. What is the opposite of false? True. So that's why here you get true. Okay. Then here you have print, then you give not, and after that, here you have a list. Inside the list, you have values 1, 2, 3, 4. So this is not an empty list. That means it is true. What is the opposite? What is the opposite of true? It is false. Okay. So just run this particular cell. Then moving on, next we have comparison operators. Comparison operators are like these couple of signs: greater than, less than, greater than is equals to, less than is equals to. Okay, so print 2 greater than 11. Is 2 greater than 11? 2 is not greater than 11. That's why you get false here. Then print 2 greater than is equals to 11. 2 is greater than or equals to 11. No. So again you get false here, because ultimately comparison operator is also your a kind of operator, and that will return you the boolean results only. Okay, in terms of true and false. 6 is greater than 5. It is true, so that's why you get true. Then 6 greater than is equals to 5. 6 is greater than or equals to 5. It is definitely greater than 5, so it is true, because here both the conditions are checked. Any one, if it is true, then it returns true. Then even in case of decimal points also, you can check print 5.8 greater than 1.2. It is true. Then here now, if you want to do like you see in this particular cell, here print, then you have integer value 12, and this integer value of 12 you are comparing with a string value, which is small a. Small a is a string value and 12 is the integer value. Now you cannot do this. Here you have used the greater than sign. It will compare the two values. But for comparison, here you have this instance of int and string. Instances are not matched. Here you have the instance of integer. Here you have the instance of string. So that's why you get the type error when suppose now first of all let me run this, you get this type error. Okay, not supported between the instances of int and str. But in case of boolean value, there won't be any problem. Like print 2 greater than true. Print 2 greater than true. What is the equivalence of true? In integer format, it is 1. So internally, here what it shall do? It shall compare 2 with 1. Print 2 greater than 1. Is 2 greater than 1? Yes, 2 is greater than 1. That's why here you get true in the output console. So just run this particular cell. Now, for here, what you can do is that print, if you want to do string comparisons, then also you can use this greater than, less than, greater than is equals to, less than is equals to operators. Like for example, here you have string value A, capital A, string capital A, and here you have string capital X. So print A less than X. Here you have capital A, here you have capital X. Print A less than X. Is A less than X? It is printing it as true. Why and how? You see, here the ASCII values are taken into considerations. ASCII stands for American Standard Code for Information Interchange. American Standard Code for Information Interchange. Here internally the ASCII values are compared. What is the ASCII value of A? It is 65. ASCII value of capital A, it is 65, and ASCII value of capital X is 88. So internally what is happening? Print then 65 less than 88. 65 is definitely less than 88. That is why it is printing true here. Now, if you want to find out the ASCII values, then there is a function known as the ORD function. ORD odd. ORD odd function. Via this, you can basically get the ASCII values. And inside that, inside the ORD function, you'll have to pass the characters. That is the string values you have to pass. Like capital A. This is a string value inside the quotes. So ORD of A, that shall give you the ASCII value of A, capital A, which is 65. Then again, you are using this odd function. Inside this odd function, you are passing the string value, which is capital X. So ASCII value of X shall be returned here, which is 88. Then again, here you're using the odd function, and what you're passing inside the odd function, capital Z, which is again a string value only. So ASCII value of capital Z, just like ASCII value of A got here computed, ASCII value of X got computed here, ASCII value of Z will be computed, which is 90. Okay, and just run this. Yeah, here also just run this, then move to this particular cell like ORD. Now capital A to capital Z, ASCII value wise, if you go, it will be from 65 to 90. And again, you have from small a to small z. Small a to small z, the ASCII values will be from 97 to 122. 97 to 122. Okay, that will be the ASCII value range for small a to small z. So odd of small a is what? It is 97. Then odd of small x is what? It is 120. Odd of small z is what? It is 122. Okay, just run this cell. Then you come down here. Now, if the opposite you want to find out, that is, you have the ASCII value and you want to find out the corresponding character or letter or the the character value, then you can use this function CHR. Inside that is CHR function. If you use inside this, you will have to pass the ASCII value and shall give you the corresponding string or the corresponding character or letter, like chr. Inside chr function you have passed 68, 65. 65 is the ASCII value. ASCII value of what? ASCII value of capital A. So this string capital A is returned here. Then again you use chr function. Inside this you pass this value 88. This will be treated as your ASCII value. And what is the correspond in case of ASCII value of 88? What is its corresponding string value? It is capital X, which is this character or letter. Okay. Then similarly, inside the chr function, you pass this value of 90, which will be treated as an ASCII value, and its corresponding string value shall be returned, which is your Z. And similarly, you can go for chr 97. Chr 97 shall return you small a. Okay, chr 97 shall return you small a. Then chr 120, this shall return you small x. Then chr 122, this shall return you small z. Okay. Now here, suppose now just let me run this. Yeah, everything is okay. Now print inside this you give Germany greater than Ghana. What will happen here? ASCII value comparisons will happen. ASCII value comparisons will happen. G and this G first will be compared. Capital G and this capital G, both of them are equal, because internally ASCII value comparison will happen. ASCII value of this capital G and ASCII value of this capital G are the same. Then ASCII value of E is compared with the ASCII value of H, and the ASCII value of H, that is small h, is greater than the ASCII value of small e. So that is why here you are getting this result as false, because ASCII comparison is happening where you are asking Germany greater than Ghana. No, because of ASCII comparisons. Okay, small h has got higher ASCII value than small e. So that's why you can say that Ghana is greater than Germany in terms of ASCII value comparisons. Internally, that shall happen when you use this operator, like here, you use the greater than operator. Okay, that's why it returns false. Then further, ORD. Inside this ORD function, you pass this character or string, that is small e, and what do we get? 101. It is what? It is the corresponding ASCII value of this small e, where this small is what? This small e is a character or letter, which is a string value. Then again, inside the string ORD function, you pass this character or letter small h, and the ASCII value of small h you shall get, which is 104. Run this. Yeah. Then next we have the equality operators. Next we have equality operators like like equal to. Okay. Then not equal to. Okay. Like equality operators will be only checking for equals to or not equals to. This is for equal to, that is equals to sign, and here you have the not equal to sign. Okay. These are the two equality operators. So an equality operator will always return a Boolean output and used for comparison among values. Now for here you see print capital Z equal to capital Z. Both are string values, so internally ASCII comparison will happen. So the result should be true, and here you get the result is your true, isn't it? Then for the second, print this Z not equals to Z. Both of them are having the same ASCII value. Capital Z, like here the ASCII value of capital Z is what? 90. Here the ASCII value of capital Z is what? 90. 90 not equals to 90. No, that is false. 90 is equals to 90. Okay. Then here like print 10 equals to 10. Definitely you get true. Then print here you see 10.0001 equals to 10. No, it is false. Because why? Because of this 1. Even after decimal, you have all these zeros, and then at the right, at the bottom, at the cornermost, you have one. But still, due to the presence of this one, Python will treat these two as not equal to each other. Then print a is not equals to b. Definitely not equals to b only. These two are having different ASCII values. ASCII value of A is 65, ASCII value of B is 66. 65 is not equals to 66. So that's why it is given as here. It is given here as true. That yeah, it is true. A is not equals to B. Then print 6 not equals to 6. 6 is equals to 6. And if I write print is 6 not equals to 6, it is false. Both of them are equal to each other, isn't it? So that's why here we get false. Then next we have assignment operator. This is very easy. Next we have assignment operator. Right to left associativity is followed. Okay, right to left associativity is followed here. This we know already, like xx is equals to 200, and then print xx, and associativity will be followed here from your right to left. Okay. Then next we have membership operator. Next we have membership operator. How this will operate? It basically inspects. It basically, inspects whether a particular element is the member of a container, that is iterable, string, list, tuple, etc. or not. This we shall see in the next class. Okay. So if you have understood this class, you can hit the like, share, and subscribe button, and press the bell icon for notifications. And if you have any doubts, you can keep them. You can write down in the comment section. So that's it for this class. Thank you.